In this lecture, we solve the question: if u is equal to sine inverse of x plus y upon root x plus root y, then prove that 2x del u del x plus 2y del u del y is equal to 10u. We have to we have given that the function u is equal to sine inverse of x plus y upon root x plus root y. Let us give it equation number 1. Then we have to prove that 2 times of x del u del x plus 2y del u del y is equal to 10u. Now, we have already known about this thing that if the term x del u del x plus y del u del y term will come, then ultimately we always use the Euler's theorem or deduction of Euler's theorem. So now here we use the deduction of Euler's theorem for homogeneous function. So what is this? If z is a homogeneous function of two variables x, y of degree n and z is equal to f of u, then x del u del x plus y del u del y is equal to n f of u upon f dash of u. F dash of u is nothing but the derivative of f of u. And the second term is x square del 2u del x square plus 2xy del 2u del x del y plus y square del 2u del y square, which is equal to gu whole times of g dash u minus 1, where this is nothing but g of u. G of u is what? It is n times of f of u upon f dash of u. Now, since in this example we have to only use the first, we have to only prove the first order partial derivative, so we only use the first result of the deduction of Euler's theorem. From 1, we have u is equal to sine inverse of x plus y upon root x plus root y. So let z is equal to, now we have to replace this to this side. So, and we consider it is z equal to sine of u, and which is equal to x plus y upon root x plus root y. Now we want to check that this is homogeneous function or not. So let us divide and multiply x in the numerator as well as denominator. So x into x into x upon x plus y upon x. Similarly, we can multiply and divide by root x in the denominator. So root x upon root x plus root y upon root x. It can be written as, since the power of x is 1 over here, so we write down x to the power 1. And here the power of x is 1 by 2. So if we take it into numerator, its power will become x to the power minus 1 by 2. Now this okay, this is not this is extra term. So what is remaining here? X by x is 1, and this is y by x divided by root x upon root x is 1 and root y upon root x. So it can be written as x to the power 1 by 2, because 1 minus 1 by 2 is 1 by 2. And this term can be considered as the f of y by x, which has 0 power. So it gives us here z is a homogeneous function of x and y of degree 1 by 2, and z is equal to f of u, which is nothing but sine of u. Hence, by deduction of Euler's theorem, x del u del x plus y del u del y is equal to n f of u f dash of u. Here, f of u is what? It is sine of u. So, which is equal to 1 upon, n is equal to 1 upon 2. And f of u is sine u. And f dash of u means derivative of sine u with respect to u. So now we can multiply whole equation by 2. So this will become 2x del u del x plus 2y del u del y. And sine u, derivative of sine u is cos u. So this is nothing but 2x del u del x plus 2y del u del y, which is equal to 10u. And this is our result, hence proved. Thank you.